This game is intense, dude.
Dude, Peyton Manning is the bomb!
Yeah, Elvis Dumerville's gonna sack him.
Dude, no, Peyton Manning all the way.
All day.
Peyton Manning's gonna throw for like 10,000 yards today. Broncos are terrible.
4 sacks in the game.
I guarantee you that Dumerville doesn't get a sack. Alright, man, dude, I'm getting really thirsty here. You should totally go hook me up with some waters.
Alright, no problem.
Yes, it's poisoned!
Color change cool, baby. Cool.
Dude, you totally missed it.
Oh, I did?
Dude, Peyton Manning just torched Elvis Dumerville.
Oh, man.
Dude, what is this? Why?
It's color change Kool-Aid. I found it.
Alright,
mine. Look at mine.
Alright, man. I just really don't. That's just kind of freaking me out, but man, that's.
It's good. Just trust me.
Dude, that game is killer. Peyton Manning. Oh,
yeah.
What do you want to do now?
I gotta admit it. Want to go play some Echo the
Oh, dude, that totally sounds good. But dude, my heart. Oh my.
Don't you want to defend the future?
Dude, I can't breathe.
Are you okay? Chad, are you okay? Are you okay, Chad?
Oh my god.
Hello, 911. There's my friend just passed out. We were watching the Broncos game and he's like, I can't breathe, and he just passed out. You'll be here? Alright, thanks, bye.
What happened? Is he okay?
I don't know. Me and my buddy were watching the Broncos game, drinking some color change Kool-Aid, and he just passed out.
How long has it been since you gave him the
I
Kool-Aid?
don't know, 15 minutes?
I'm sorry, I can't find the pulse. He's gone.
Is there anything you can do?
No, I'm sorry. I didn't get here in time.
Why me?
Well, actually, I can explain if you have a piece of paper.
Do you know when the last, possible moment you could have gotten here to save him was?
We can use the mean value theorem to figure it out. On the interval of 0 minutes from when you first gave him the poison to 15 minutes when he died is where we can figure out his average decreasing pulse. Using the mean value theorem, which states that the function of b minus the function of a over b minus a will equal the derivative of c. The function of his heart rate would be shown by negative x squared plus 10x plus 75 equals f of c. So we plug the values from the interval into the function, so you get 0 for 15 minus 75 for 0 all over 15 minus 0, which equals negative 5. Therefore, his heart was decreasing at a rate of 5 beats per minute, meaning I would have had to arrive when his heart was decreasing in pulse before his heart was decreasing at 5 beats per minute. Because this is the average rate his pulse was decreasing, according to the mean value theorem, there must be some time where his instantaneous rate of his decreasing pulse matched the average rate of his decreasing pulse. In order to find this point, I set the derivative of the function, which is negative 2x plus 10 equal to his average decreasing pulse. Then I solve for x, and I find out that at 7.5 minutes his pulse was decreasing at a rate equal to his average decreasing pulse rate, which means I would have had to arrive before 7.5 minutes after you gave him the poison to save his life.
The AMT is right, and I will support this graphically. So, we have our graph of the function which the EMT correctly determined here, of negative x squared plus 10x plus 75 is equal to the function of which his heart rate decreased. So this is his heart rate, or his beats per minute. That's a W. The beats per minute. This is time. So his heart rate looked like this. This is the initial point where he took the poison. The heart rate increased until it got to 100 BPM. 100, and then after that it decreased down until the point of death, where his heart rate equaled 0. So this is his point of death, or 15 minutes in. 15 minutes, and this is 0 minutes. Connecting these, his average heart rate decreasing had a slope of -5, which is shown by this calculation here. As the time equals 0, this is the point that he ended at time equals 15. By finding the slope of the line by a simple slope equation, we can find that the rate was -5 BPM per minute that his heart decreased. Now, based on the MVT theorem, there must be at least one point on the slope of this graph where the slope at a single point equaled -5, which was the last point where the EMT could have saved her. Now, to calculate this, we would take this slope and set it equal to the derivative of the graph, which is -2x plus 10, find the point, which happened to be 7.5 minutes in. So, at time 7.5 minutes, the slope at that point, at 7.5, was equal to the slope, the average slope of the function, or -5 BPM per minute.